Hi, guys. Okay, so symmetry, I feel like you already kind of know. So here's just the general recap. It's only helpful because if you can like pick out pretty quickly if something is even or odd. We good?
It's like, yeah.
I like watching you on that.
It's too high. Okay, there you go.
Okay. Because like if you can tell if something is even or odd pretty quickly, it just helps you know like either it's going to be symmetrical or symmetrical the other way or not at all. So it's really not that big of a deal, but I know that it's going to show up in like the midterm, so it's worth going over it real quickly. If something is even, the way I think about it is the most general even function would be y equals x squared. That helps me remember what's what, because it's got an even power. So it's got an even power, it's the most general even function. So even must mean I'm symmetrical to what? The y-axis. That's my way of cheating in my mind so I know, I remember the way it goes. That y equals x squared has an even power, it looks like that, and it's symmetric to the y-axis, so that's what even means. And the definition of an even function is that if I take f of x and I replace all of my x's with negative x's, I should be able to get back to what the original function was. Did you learn it this way before?
Yeah.
Okay. So for example, with x squared, if I replace x with negative x and square it, I get back to x squared. Because when I square it, the negative times the negative is a positive. So that's even, and it's pretty easy to figure out. One example of yes, it's even, would be something like this. Because if I take this function and I replace all of my x's with negative x's, it just goes away, basically. Because every time I plug in a negative for x squared, I'm going to just get x squared. And a negative in x to the fourth, I just get x to the fourth. Do you know what I mean? So if I plug in a negative, I get back to the same original function. But an example of no, it's not even, would be something like this. Okay, because if I take f of negative x, that would mean putting a negative x in to all the places where I already have an x. And negative x squared is just x squared. Hooray, that gets me back to the normal original. But making this one a negative changes this to a plus. And uh-oh, frown face, they don't match. So if you're trying to figure out if something is even, you'll replace all of the x's with negative x's, reduce what you get, and if you're back to what the original was, great, it's even. If you're not, then it's not. Easy enough? Okay, so odd, similar. Y equals x to the third is your most basic odd function. It's got an odd degree. And it looks like this. So instead of saying this is symmetric to an axis, what do we say it's symmetric to?
Origin.
Good. I think origin symmetry is kind of odd. We talked about it the other day, I feel like, for a second. Oh, origin symmetry is odd. I didn't even mean that to be a little fun. By definition, if something is odd, it means if I go and replace every x with a negative x, it's not that I get the original, I get the opposite of the entire function. So an example of something that, yes, is odd. Am I going too fast? I don't want you to just write, I want you to make sure you can listen too. Something like this is odd. odd because if I go and replace my x's with negative x's, so I figure out what's f of negative x. So I put in a negative here, and I put in a negative here. Well, what happens to that is this negative x to the third is negative, because negative x times negative x times negative x will give me back to a negative. This is also negative, and I have that. Well, if I compare this to my original, if I just like factor a negative out of the top, it is the opposite of the original. It's like I'm applying a negative to the entire function, and that if I apply a negative to this entire function, I get this. The only thing to be clear on with fractions is if I had gotten negative x to the third plus x or whatever over negative, would that be the opposite or the same? It'd be the same. So if I got a negative over a negative, since they would cancel out and become positive, that would get me back to the same thing as the original function. That would be a no. Okay, that wouldn't be odd, because it'd be getting me back to the same thing as the original, not the opposite. So would that be even? Yes, that would be even. Like I said, it's not like the biggest deal ever. Are there any huge questions on this, or is it like, okay, I know you've seen it before. All right, and one other just quick thing. Everyone know how to find x and y intercepts? If I asked you to find x and y intercepts for y equals 2x minus 3 over 4x plus 1. If I was finding intercepts for this, this is a dumb thing to say, so sorry, but sometimes I'm like, okay, which one, when x is 0, which one is that? Is that an x intercept or is that a y intercept? And obviously if I think about it long enough, I can figure it out. But I don't really care if you tell me which one's the x, which one's the y. We just want to know what happens when x is 0 and what happens when y is 0. What are the points that go with them? Because those are the intercepts. I mean, obviously, when x is 0, that's a y-intercept, and when y is 0, that's an x-intercept, but so what, whatever. Just figure out what happens if I plug in 0 for x, and what happens if I plug in 0 for y. Now watch this part to make sure you're really comfortable. If I plug in 0 for x, look at how easy this problem is. Because you don't want to take a whole lot of time with it, you want it to be pretty quick. 0 for x means that's gone and that's gone, so what's the y value? Negative 3. Okay, try to do it that quickly. Just be like, all right, if I plug in 0 for x, negative 3 is what I have left. And if you plug in 0 for y, just think, I don't have to worry about the bottom. If I'm plugging in 0 for y, I can basically like cross multiply, and the bottom times this would be 0, it would just go away anyway. So if I want to know what happens when y is 0, just set the top equal to 0. And what would you get? 3 halves, or 1 1/2, and there's no intercepts. That's all we're going to do today. Tomorrow, we're going to put it all together and graph like huge, crazy things. So we have a little bit of time now to finish the whatchamacallits. There are a few homework questions. It should take you like 3 minutes. They're really pretty quick. It's just even odd. I want to make sure you're okay. If you totally get even odd and you want to skip it, fine. If you want to make sure you know what's going on, just flip open your book and try these and check them in the back and make sure you feel okay.